2.3 is going to be our last section prior to our test. So test 1 will be all of chapter 1 that we've covered, and then 2.1, 2.2, 2.3. So 2.3 goes hand in hand with 2.2, which we just got done doing. It's math with functions, but instead of your typical computations that you guys know of, it's a new computation called the composition, okay? His symbol, it almost looks like we're spelling fog, guys, but his symbol is like this little, it's not even an O, it's like a little circle. It's a little bit smaller than an O. So this just read F composed with G. Okay, it's the composition of F and G, and how it's defined is whatever is on the outside, so whatever's the furthest left, is considered the outside function. Okay, and whatever's furthest right, notice he goes into the inside. All right, so basically when we're composing functions, we're using one function and we're putting it in for X to the outside function. Okay, so we have this whole idea of inside, outside. So he's the outside, the furthest left is the outside, and then he's the inside. And we'll talk about domain. I honestly do domain kind of at the end, but it says where X is in the domain of G, so we got to make sure we can even put it in the G. And then G of X, whatever pops out, is in the domain of F. So it's kind of a weird thought process because we don't know what G of X might be. So we have to be careful with that. So how we do this, I kind of did exactly like the 2.2 extra practice that we just did. We're going to find the composition of the two functions generically with X, but then we're going to use the exact same functions and the exact same compositions, but we're going to evaluate them at 2. Okay? And I'm actually going to show you both ways. The one that Shia was kind of doing, like we can plug 2 in first and do the math, or we can find the function, because we did in A and B, and then plug in 2. Okay? So how I write this, whenever you need to find f of g, so it looks like fog, I always rewrite it as this, f of g of x. I do that so I remind myself who is the outside, who is the inside. Okay, so this is where you kind of just have to have like an abstract way of looking at things. Do you guys agree that f has 3x minus 1, so it only has one variable, x, right behind the 3? So what are we going to plug in for x? G. So I keep f like this. F will be the outside, but what is g of x? Do you guys agree with that? All I did was plug in what g of x actually was. It's just a substitution, right? So I want to take f of g, but what is g? It's the parabola x squared plus x minus 3. Okay? So what does that mean? It means in for x, wherever I see x and f, what are we putting in there? X squared plus x minus 3. So we already kind of had a section like this, like chapter 1, where we had to evaluate x plus 1 or x minus 2, right? So we're just going to do it with other kinds of functions. So what does this mean? It means take f. What is f? 3 times x. 3 times, but what is our x? This is x now. So we're going to take 3 times x squared plus x minus 3. And then what else is f of x? It's 3 times x, and what can't we forget to do? Minus 1. Were you here that day? Were you here that day when we found, let me write on the board over here. Remember when we'd have a function and then we'd have to find like f of x plus 1?
Yeah.
And this is always what we plugged in for x. We're doing the same thing, but our function, it just happens to be g, right?
Yeah.
So what is g? G is that quadratic x squared plus x minus 3. So from this step to this step, I just put in what g was.
Okay.
Does that make sense? So see how they say g's right here? So I know g is going to be my x. So what is g? That quadratic, x squared plus x minus 3.
Where'd that 3 come from right there in the front?
I'm plugging him into f.
Okay, that's not also
Yep. So g is our x, right?
Yeah.
But we have to plug him into f. What is f? 3 times whatever x is. So we need 3 times g.
Which is the x.
Mm-hmm.
Got
And then minus 1.
So that's
Minus 1. Okay? So notice we have 3x minus 1. Our x is just really ugly. Okay? And that's what's going to happen. We're going to take the inside function and put them wherever we see x and the outside function. Okay? It's kind of like what we did yesterday when we did f of x plus h, right? Remember with our difference quotient, wherever we saw x, we had to put the quantity x plus h. We're doing the same thing in this section, except for it's not always x plus h. It's a parabola, or it might be a line, who knows, okay? So what do you think our next move is going to be? distribute, right? Let's get rid of those parentheses. So let's bump the 3 into all 3 spots. So it will be 3x squared plus 3x minus 9 minus 1. Is that okay? Because it was just 3 times x minus 1. Can we combine anything with the 3x squared?
No.
Nope, so he's going to stay 3x squared. Can we combine anything with the 3x? Nope, so he'll stay 3x. Can we combine the negative 9 and the minus 1? We can. That will become negative 10. So what you guys just did is you found a new function. It's called f of g, or f composed with g, where we plugged a quadratic into a line. It's kind of weird to think. And what popped out? A new quadratic. Okay? See if we can do the reverse. Okay? So notice I am not changing up what f or g are. G is, g are, f or g, I don't know. So I'm not changing our functions, f and g, at all. I'm not changing them. But I am switching the order in which we're composing them. So now who's the outside guy?
G.
The g, right? And now who's the inside guy? The f of x. Perfect. So I'm going to write it like that. G of f of x. And what does that mean? It means into everywhere I see x and g, I will be writing the function f of x. So let's say what that function is. We want g of what? Well, what is f of x?
3x
Minus, perfect. I think this one's a little bit easier because it's just a binomial versus a quadratic. So where's our new x, guys? Right here. This is x, right? And some teachers, when they teach this, guys, they teach it with like colors. But sometimes I have to stop and think, okay, what color do I need? You know, like the red is the inside and the black is the outside. So what we're going to do is we're going to take g. He has x squared plus x minus 3. But instead of x, what are we going to put in? 3x minus 1, okay? So we have x, that's 3x minus 1. But what do we have to do to x? Square him. Then we have plus x, so we're just going to put plus x. And then what do we have? Minus 3. So do you guys see it? We have x squared plus x minus 3.
It's ugly.
It is very ugly. I'm not going to sugarcoat it. It's not pretty. But see how it mimics our quadratic? Whatever the term is squared plus the term minus 3. So now what's ugly is that we're going to have to FOIL because we have a quantity squared. So we're going to rewrite this as 3x minus 1 times 3x minus 1. He can pop out of, the middle guy can pop out of his parentheses because there's nothing in front or anything. So that's just going to be 3x minus 1, and then we're going to have minus 3 there. Okay? So all I'm doing is saying I want to get rid of my parentheses so I can gather like terms. So since this is a quantity squared, I'm going to take it times itself twice. Since the second guy has nothing in front that I need to distribute, I'm just getting rid of his parentheses completely. So 3x minus 1. And then the minus 3 is like, hey, I'm just a constant. I'm the easy guy that's just going to hang out while you do all that other math. All right? So help me distribute. Again, people use the term FOIL, but I like the word distribute. Help me distribute the 3x minus 1. So we're going to take 3x times 3x. What's that going to become? 9x squared. Perfect. And then we're going to take 3x times a negative 1. So it'll just be a negative 3x. Is that all right? So we've officially distributed the 3x to both parts. Now I'm going to take the negative 1 and distribute him. So negative 1 times 3x will be negative 3x, but then negative 1 times negative 1 is actually a positive 1. And then who do we have behind it? 3x. And then is that okay if I just go ahead and collect those? What's minus 1 minus 3?
Yeah.
Minus 4. I just try to kind of gather things as I see them. You can wait till the very end to do all of that, though. Like, you can go through the motions.
Is this? Oh, no.
Okay, so what we're going to do is now that we have it kind of all the parentheses are out, we should be able to combine like terms now that we've gotten rid of things. So can anybody combine with 9x squared?
No.
Nope, so he'll stay 9x squared. But what about the 3x's?
Negative 6.
You got it, negative 6x. And a lot of people want to say they cancel out, but they don't, right? We have a negative 3 and a negative 3, which makes a negative 6. So they actually combine to be more negative. And then, oh, I lied. Because who else do we have hanging out?
All the other 3.
The other 3x, right? So it's exactly. So I was really quick to judge, but I want to get it all done in one little foul swoop, right? So we have negative 3 minus 3 is a negative 6, but then we go add 3 more. So we're actually sitting at a negative 3x. Is that okay, guys? And then we have 1 minus 4.
Negative 3.
-3. Beautiful. You guys just find the new function. And it's crazy to think. We only had two functions, f and g. But when you combine one with the other first and vice versa, we get two completely different answers as far as our composition. This is where I said you can actually compose a function with itself, which is really weird to think. You can put f into f if you want, and you get a new function based off of that.
I know this might be like a stupid question, but
No.
how would you use this in like
Real life. A lot of things like company-wise or like even salary-wise could be something where like you have a baseline salary, then but based on what you get, like maybe commission, you're put into a different like chunk of what you make on commission. You know what I mean? So like your inside function would be your sales and how many you sell, right? And so then you get a certain amount of money based on that. But then, depending where you are, they put you into a new formula to calculate your commission. Or something like that, right? So like, it's just when you have kind of like a two-step process, basically. Okay. And I can go look up some more ideas. That's the thing that comes to my mind first, is just like, okay, I have this initially, but based on what this is, it makes the second part different.
That
okay?
makes sense to me because I work in sales.
Yes, exactly. So you know commission, like different levels of commission, you get different gold members or whatever, and depending on where your output is on your sales, then you're placed into a different commission bracket, and that's kind of like what we're doing. So let's see what happens when we evaluate, okay? So there's two ways to evaluate. I think the easiest way is if you've already done the hard part, like we've already done A and B, the easiest way to evaluate the number 2 is just to plug 2 in, right? We already know what f of g is. It's this function right here. You guys agree?
Yeah.
So I'm just going to put 2 wherever I see x. So this will be 3 times 2 squared plus 3 times 2 minus 10.
I like
That one's not bad, right?
it.
8. Did you guys get 8? So what does this end up being? 3 times 4 plus 6 minus 10. So 12 plus 6 minus 10 equals 8. Perfect. Okay. Now I'm going to show you something, and I don't mean to show it to confuse you. So like, if you like this way, you're going to be like, la, 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 right? Another way, sometimes they don't ask you to do this step. They don't ask you to find the generic. They want you to just go right here. So what could you do? You could do this step on your own and then plug 2 in. Or what we can do is we can write it this way. We want to find f of g of 2. We want to find f of g of 2. So like I said, I think if you've already done this, it's really easy to just plug it in and be done. But an easier way might be if they don't ask you to do that and they go straight to evaluating, what we can do is just plug 2 in for g and go from there. Okay, so let's see if we can figure this out. So let's just figure what g of 2 is. Let's just figure out the inside number. What's the inside number? Well, we're going to plug him into g, who's way up there, right? So we'll have 2 squared plus 2 minus 3. You guys see what I did? So I just took
So you
g.
just, instead of x, you just put
2. And he's your inside, right? What pops out when you do that? I think you get, is it 3? Is everybody okay with that? So 2 squared is 4. 4 plus 2 is 6. 6 minus 3 is 3. You're like, well, Molly, that doesn't match 8. Well, what have you only done?
that part.
The inside part. So what am I going to do?
You're good.
What am I gonna do?
That in for f.
Exactly right.
So it'd be
This is
for-
the whole input-output that we're talking about,
Oh,
right?
That would be. Oh, that sounds easy.
It's not bad either way. So this is the whole, this kind of like, okay, I made sales, and so based on my sales, I'm sitting at 3. But then now I want to know my commission, so plug me back into whatever my commission formula is and pop it into F and see what pops out. I mean, it's like you can kind of really see the inside outside, okay? So this is just the X now for F, right? So step 2 is just find F of 3. So you have 3 times 3 minus 1, and what do we get? 8, okay? I do not force you one way or the other. I don't say you have to do it this way or you have to do it this way. You do it the way that you see that makes sense. This is what you were doing yesterday. Remember, you were finding F, you were finding G, and then you were taking the product, or then you were taking the addition. So she was already doing this in last section's class, okay, which is fine. All right, so let's see, are there any questions on what I did there? So I just found my inside first. Let's just find out what G of 2 is, and out pops a 3. But realize whatever G of 2 is, that is now our new X, right? So even though that was a 3, we popped them into our outside function F, and we got 8 either way, okay? So let's check it with part D. Let's make sure it works for part D as well. I'm going to do it with the flat out, hey, we already did G of F. We already did G of F, so let's just plug 2 in. And that's kind of nice. You just kind of put it in and pop into your calculator. Do you get 27 when you do that?
Yeah.
Does that look good? I don't know if do I need to show all the work, and can I just put 27? Can I just put 27? You guys know order of operations? Okay.
It's already in parentheses and stuff.
Exactly. And that's why I'm saying, like, the second you put it in exactly like that, you cannot mess it up. Okay. So what I'm going to do is a big or we can find G of F of 2. Meaning, let's find F of 2 first. Meaning, I'm going to put 2 into my F function, right? So we'll have 3 times 2 minus 1. Do you guys get 5 on that? Mm-hmm. Okay. So that is now my X for my G. Okay, because he was the outside one. So now I'm going to find G of, is it 5? This one's a little bit harder because he's the quadratic, right? So up here, wherever I see X, I'm going to be putting a 5 in. So 5 squared plus 5 minus 3, what do you get? 27, okay? So it's kind of neat to just see both ways. I think this way really shows you the input-output idea. You input a 2 for G, out pops a 5, or we input a 2 for F, out pops a 5. But that is now the inside of G, so we have to plug that back in. So either way, like I said, I'm not a teacher that says you must show me both ways or you must show me this way. You pick which one you like and you go from there. The reason why I like to show this is because, like I said, sometimes they just go right to this. They don't ask you to find the generic first. They just want you to find that. So it's like, okay, the G's my inside, let me do that real quick, and then the F's my outside, and I got it. All right, so now we have to talk about domains. How do domains work? On the back there, okay? How do domains work? Honestly, they try to make it all difficult if you read about it in the book. I like domains by just going and finding the composition and get the composition at the end and figure out its domain. Because if you read the book, it's like, here, let's go back and see if this makes sense to you. The domain is where X is in the domain of G and G of X is in the domain of F. There's like a lot of words and you have to make sure. I'm like, just find what the function is and check out its domain. You know how to find domains, okay? So just find that new function. That's how I do domains, all right? So this new function is fog, F of G of X. So who's our outside function in this one? F. And who's going to be our inside? G. So I'm going to write it that way. Big F, and like, they're technically written the same, but I really try to accentuate F is on the outside, and I'm encompassing G, right? So leave F hanging out as you plug in G. What is G? 2x plus 3, right? So F is the outside, and in we're going to plug G. But what is the function G? 2x plus 3. So what does that mean? It means wherever I see X and F, what will I be putting in? 2x plus 3. So what is the function F? The fourth root. What do I have to put under him? X, but what is our X? 2x plus 3. Okay? So we would be done if they just said, find the composition of F of G, right? But that's not what they asked. They asked us to find the domain, okay? But don't we know how to find domains of even roots? You're like, we should, right? We did. We just did it on that last little practice worksheet. What do we always want to take an even root of? What kind of number? A positive, right? So we need 2x plus 3 to be greater than or equal to 0. Because we can take the fourth root of 0. What's the fourth root of 0? 0, right? But otherwise, it needs to be a positive number. So we're just going to solve the inequality like normal. subtract 3 over, so we have 2x is greater than or equal to negative 3, divide by 2, so we have x is greater than or equal to negative 3 halves. But then, guys, what they'll do is they'll just ask you to answer the domain and one of the two ways that we've learned, the set notation or the interval notation, right? So remember set notation, it's a little bit more awkward, I think. It's squiggly bracket, x such that x is greater than or equal to negative 3 halves, meaning as long as we're bigger than negative 1 1/2, or we could be negative 1 1/2, that's fine, we're okay. But how do you show this as interval notation? We want all x values bigger than this, so he's our lower bound, right? So we're going to go from negative 3 halves to where? Infinity.
This part you kind of lost.
Okay, are you okay on how we got our new function, right?
Yeah.
So we just plugged g into f and we got this new guy, but they didn't ask us to find f of g of x, they asked us to find the domain. And remember, the domain is what x values are okay to plug in. And we just tell ourselves, we're like, well, as long as we plug in an x that makes the inside of the root positive, we should be okay, because we can take fourth root of positive numbers or fourth root of 0. So that's why it has to be greater than or equal to 0. This just represents
But it has to be
positive, exactly. A way to show a number is positive is that they're greater than 0, correct? So we just solve the inequality like normal by subtracting 3 and dividing by 2. And as long as the x is that we choose is bigger than negative 3 halves, this will always be a positive number. So how do we...
Squiggly thing.
Okay, so that's what I was going to say. Way back when, if you'll go look at your notes, way back when we first introduced domain, we had two ways to write it. This was called set notation, and this was called interval notation. These are just squiggly brackets that I'm really bad at writing, okay? So it's just a squiggly bracket, and it says x such that x is greater than or equal to negative 3 halves. A lot of us tend not to use it. I feel like when I grade your papers, you guys really prefer the interval method. Do you guys?
So it would be either the top one or the bottom one.
Mhm.
Okay.
That's what a bracket
I thought it was
Yep.
both.
Yep. And then, yeah, I'll write or. Okay. I think I'm like you guys. I prefer the interval notation. So you just have to make sure you know what direction we're going. And I always say, if you kind of question it, I think it's easier to just draw a number line. And so like, say I'm like, oh, I don't know if I'm going to negative infinity up to negative 3 halves or negative 3 halves to infinity. I'll just draw a number line and I'll plot negative 3 halves and I'll say, okay, what x's do I want? I want x's that are bigger than him. So what direction is bigger, to the left or to the right? To the right. And that makes me realize that he's the lower end and then I'm going to infinity. So I think drawing the number line helps me a lot with inequalities because sometimes I question which direction am I going.
Well, the second thing is not that bad now that I look at it. It's just the squiggly line.
I can't do squiggly brackets. You guys know what I'm talking about, though.
I knew what you were talking
Somebody in one of my stats class I think it was last semester or the semester before, she made fun of me. And she's like, just take your time. So it's just like this.
Yeah, there you go.
That takes too much time.
Right?
It looks like a mustache.
You mustache? I'm going to ask you a question. Okay. I can't, so I don't do it slow, so I'm just like, and then you can't tell what it is. But yeah, it's just squiggly brackets. That's all it is. All right, so the last objective, guys, I feel like we're always prefacing and getting ready for calculus, okay? So objective 2 is actually going the reverse. So we took a function and plugged it in to get this new function. They're actually going to give us the composition, and they say, well, what was my inside, what was my outside? And to me, it's obvious, so I really struggle to like teach it. So let me know if I need to like go over it over and over again. But what it's called is decomposing. So if you compose it to make this big one, this new one, we're going to decompose it to go backwards and figure out what was F, what was G. Okay? So just constantly think inside, outside, right? So if H of X is F with G, who is the outside?
The outside is G.
Nope.
Oh.
The outside is F and the
Oh.
inside is G, right? So I'm just making a note of that. Like, so it says if H of X is this function, don't even worry about him yet. We're not going to even worry about him yet. If H is made up of a composition F composed with G, first denote to yourself who the outside is. Remember, the outside is always the first guy, and the inside is always the second. Okay? So, and then, like I said, this is where I really struggle to teach it because I just see it. I just see it, and I'm like, oh gosh, how do I get this across to my students? All right? So when you look at this function, there's multiple things going on. Do you guys agree?
Mm-hmm.
We have in parentheses 3x minus 1, but then we're doing something to 3x minus 1. What are we doing to 3? Raising it to the 4th. So who looks like the inside guy and who looks like the outside guy? Who would be the inside guy?
I guess a 3x.
The 3x minus 1, right? And what are we doing to that 3x minus 1?
Putting it on this sheet.
We're raising it to the 4th. That is g, but you know exactly right.
Okay.
That is our g, but what are we doing to g? We're raising it to the 4th. So what is f? X to the 4th.
Oh.
Let's write it and then see if we can go back and say it all over again, okay? So to me, this is the inside, and then raising it to the 4th is the outside. Do you agree? Okay? So right here we labeled who our inside function was. He was g of x. So what is our g of x? It is 3x minus 1. I don't think there's going to be any arguments there. Do you guys agree with that? It's the next part that gets a little tricky. So remember, f of x is what we're doing to g. So remember, g is just x for f, right?
Yeah.
So f of x is just simply x to the 4th. Because who are we plugging in for x, right?
Oh wait, that's not hard.
That's not bad, right?
No.
Okay, I was gonna say, I see it, so I always really struggle to make you guys see it. So your outside function will just be like always just x, but what are you doing? Okay? So your inside function is usually the more complicated one, like 3x minus 1. There's a lot more going with him. But what are we doing to 3x minus 1? We're just raising him to the 4th power. So f of x is just x to the 4th. And you're like, well, I don't know if I believe you. I don't know if I'm right. Just find f of g of x with what you have, right? Like if we wanted to check it, we would find f of g of x, correct? F stays on the outside. Who's our inside? 3x minus 1. But what does f say to do to him? Raise it to the 4th. Is that our h? Is that what we started with?
Oh, yeah.
It is. So we know we've done it correctly. Okay? So this, you do not have to do this, guys. This is just like, if you're questioning whether you did it right or like, Molly, I don't know if I'm seeing it.
So you just
Come up with something, right? And then go compose it like we were doing on the front page, right? So f of g of x is always your inside. What did we say g of x was? 3x minus 1. And once you have your inside, remember he's your x. So you're plugging him into your function f wherever you see x. So 3x minus 1 is going into it. What did we do to him? The 4th power.
But you just leave it like that?
Yeah, this is our answer. They just want to know what is g, what is f.
Well, I feel better about that.
I think this is easier than the front page.
Yeah.
I don't know. You might not be with me, but I think it's easier. So, knowing what we just did there, again, let's make note of who this is. This is f of g of x, right?
Yeah.
So who's the outside?
F.
F. Who's the inside?
G.
We got 2 minutes. Okay. So looking at this function, who would you consider the inside?
X
X plus 5. So guess what g of x is? X plus 5. But what are we doing to x plus 5? Square rooting it. So what's f of x? Just the square root of, you guys got it.
Ooh,
Perfect.